Hello everyone, this is Kik, and today's episode features developers showing how the Figure 01 android prepares to work on the BMW conveyor belt, a soft robot from MIT that can pack groceries like a human, a 12-meter robot that will repair wires on Japan's railway tracks, DJI unexpectedly introducing a mountain electric bike, and AI creating a rocket engine, EHang starting serial deliveries of the EH216S electric aircraft to its first customers, and NASA revealing the concept of the Lunar Orbital Station Gateway. We will start today's episode with robots. Almost 6 months ago, the company Figure announced that its humanoid robot had received its first job at the BMW factory. Now we can observe how Figure 01 is being trained for this role. In a new video, the robot learns to handle large, complex objects with its rubber fingers. Impressively, Figure 01 carefully places a large plate onto a platform even though it covers 2 locking pins that need to fit into holes in the part. On the downside, the robot picks up small items one at a time, whereas a human would pick up both simultaneously. However, Figure 01 correctly identifies that it is holding them incorrectly, reorients them, aligns them with the platform, and then carefully places them in the correct position. Furthermore, noticing that the items are not secured properly, the robot adjusts them with the back of its hand, correcting its mistake independently. Over time, its movements are likely to become faster and smoother. The update showcases an evolutionary rather than a revolutionary development. Figure 01 now definitely handles much more complex and interesting shapes requiring finer grasping. It is not just placing a box on a conveyor belt, but aligning intricate parts and placing them into high-precision fixtures. Although the video ends with the caption BMW Group Spartanburg plant, it appears the filming took place on a test stand in the Figure company's own building. If so, it remains unclear when Figure 01 will actually start working on the BMW production line. The Massachusetts Institute of Technology (MIT) has presented RoboGrocery, a system that uses computer vision and a soft robotic gripper to automate grocery packing. To test the system, researchers placed 10 unknown objects to the robot on a grocery store conveyor belt. The products ranged from delicate items like grapes, bread, cabbage, muffins, and crackers to much harder ones, cans of soup, food boxes, and ice cream containers. During the packing process, technical vision first activates to recognize the objects and then determines their size and location on the belt. When the gripper touches the grapes, pressure sensors detect that it is a soft item that can be easily crushed. Therefore, it cannot be placed at the bottom of the bag. The system then recognizes the can as a harder item and places it at the bottom of the bag. According to the researchers, this is the first step towards robots being able to pack food and other goods in real-world conditions. The concept is not yet ready for commercial implementation, but the research demonstrates the effectiveness of integrating various sensor modes into soft robotic systems. Researchers say the system can be improved. For example, upgrading the gripper and cameras would allow the robot to better understand how and in what order to pack items. In the future, the technology could be used not only in stores but also in industrial settings, such as recycling plants. In Japan, a 12-meter robot will repair wires on railway tracks. This robot was jointly developed by 2 companies, Jinki Itai Co., which specializes in robotics development, and Nippon Signal Co., which specializes in IT solutions and electrical engineering in infrastructure. Jinki claims the robot can lift and move heavy loads such as steel pipes, sheets, or wires, performing work just like a human, as it is controlled by an operator. Thanks to synchronized movements with the robot, the human operator can use the machine to perform complex tasks requiring both strength and precision. The robot essentially mimics the movements of a real person located in a control room. The operator's special glasses are synchronized with the robot's eyes, and the powerful arms are controlled using the company's proprietary technology. It is expected that using the giant robot will be a significant step forward in railway maintenance and safety. This solution will help address existing issues in the industry, providing more reliable and efficient railway line maintenance. Moreover, the robot is estimated to reduce the need for labor for most tasks by 30%. Mechanization will not only reduce the risk of accidents caused by electric shocks or falls, but also create conditions for a more diverse work environment. The new robot will also be used for felling trees, removing obstacles, painting infrastructure objects, and replacing signal equipment. Moving on, EHang conducted passenger demonstrations in China on June 22nd. Several people took a short sightseeing tour in the unmanned EH216S aircraft at a low altitude, enjoying the views of the mountains and lakes around the Baijiangji waterfall and Feiyun Lake Resort area in Wencheng. Wencheng, a district in the city of Wenzhou in China's Zhejiang province, aims to become a pioneer in the emerging low-altitude economy. This sector involves the use of manned and unmanned aerial vehicles at altitudes below 1,000 meters for passenger transportation, recreational purposes, cargo delivery, emergency response, and other services. The Wenzhou authorities have placed a deposit to order another 270 EH216S units, which will be delivered by 2026. EHang will work with Wencheng authorities and enterprises on further developing infrastructure for electric aircraft. As part of the cooperation, several routes for eVTOL sightseeing flights will be identified, with regular flights expected to launch by the end of 2024. Opportunities for using the aircraft beyond tourism, such as in emergency response and logistics, are also being considered. Although most of Wenzhou's infrastructure for supporting EH216S flights and services is still under development, the Baijiangji Resort, where the June event took place, has already built a takeoff and landing pad along with associated charging infrastructure. Similar pads are planned to be built throughout the region in preparation for the launch of commercial sightseeing air transportation on the EH216S. Located in southwestern Wenzhou in eastern China, Wencheng is known for its waterfalls, mountains and gorges, lakes and dense forests. It will provide an ideal backdrop for aerial tours. Seeing the opportunity to become a global leader in advanced technologies, the Chinese government, following the implementation of favorable regulation and certification of the developing eVTOL industry, is actively promoting investments in the air mobility economy. It is expected that this market will double and exceed 138 billion United States dollars by 2026. DJI, known in the drone market, has unexpectedly released its first mountain electric bicycle, the Amflow PL. The new product is equipped with an Avanox engine, a battery with fast charging capability, and a set of smart features. The proprietary Avanox drive system has a nominal power of 250 watts with a peak rating of 850 watts. For particularly steep slopes, there is a boost mode, which provides 1000 watts of peak power and 120 Newton meters of torque. A 2-inch OLED touchscreen displays the ride metrics. The Amflow PL also comes with the Avanox mobile app for wireless access to data, functions, and bike location tracking. The Amflow PL features 4 ride modes, including an automatic one that adapts power delivery based on resistance, a built-in USB port for charging a smartphone or bike computer. The new bike weighs only 19.2 kilograms. The carbon fiber frame accounts for 2.27 kilograms and the drive system 2.56 kilograms. It can accommodate both 27.5-inch and 29-inch wheels. The DJI Amflow PL is expected to go on sale in the 4th quarter of this year and will cost between 7,000 and 12,000 euros. Researchers at the University of Sheffield in the United Kingdom successfully tested the world's first liquid rocket engine fully designed by artificial intelligence and printed on a 3D printer. Amazingly, it worked on the first attempt. The development began with the approval of the engine specifications, which took less than 2 weeks. Printing the components took a few more days. The most time-consuming part was refining the details, as university staff did this manually. The reason is that AI mechanisms are not yet ready for such precise physical work. Despite this, the entire creative phase was handled by artificial intelligence. This was made possible by the Neuron computational model. The engine's power is 5 kilonewtons. During the tests, it ran for 12 seconds and developed a thrust of 20,000 horsepower. Its components are made from a copper alloy, QCAR-ZR, using additive manufacturing with an EOS M290 printer. Kerosene was used for cooling, supplied through channels with a diameter of 0.8 millimeters to bring the engine temperature to 250 degrees Celsius. The chamber temperature in turn reached 3,000 degrees Celsius. And what would Kik be without space? NASA shared the concept of the Gateway Station. Potentially, it could become the first space station in lunar orbit and the first key transportation hub above the surface of the Moon. It may be used in future Artemis missions planned for the 2030s. The design and development of Gateway involve European countries as well as Japan, Canada, and the United Arab Emirates. It is planned that from the second Artemis 4 mission, the station will be used as an operational center. The central node will be the habitation communication and logistics outpost, Halo module, a cylindrical room designed to house the crew. In the absence of astronauts, the module will operate autonomously. Instruments for measuring radiation levels and other equipment can be stored inside it. The module will run on solar panels capable of generating 60 kilowatts of electricity. They will also power the propulsion system and the xenon gas ionization system. The gateway will be located in orbit at a distance of 3,000 to 70,000 kilometers from the lunar surface. If everything goes according to plan, the first module will be put into operation in 2028. And that's all for today. Thank you for watching. Don't forget to subscribe and hit the bell to stay updated on high-tech news. Peace to your home.